let's record. There we go. All right. So product rule and quotient rule. We'll actually do the product rule. We'll take 15 minutes, maybe 20 minutes, let you work on that, and then we'll talk about the quotient rule. All right. If we have two functions, f and g, and they are both differentiable, we can take the derivative of f, we can take the derivative of g. Then the derivative of f times g is f times the derivative of g plus g times the derivative of f. I always say it's the first function times the derivative of the second plus the second function times the derivative of the first. That's the way I remember it. A couple things to take note of. Because we have multiplication and addition, I could swap the order. I could take the derivative of the first times the second, and then the first times the derivative of the second. That doesn't matter. But make sure we're adding in between. All right. So if we have our function f of x defined as x times e to the x, find the first derivative and then find the nth derivative. In other words, find a general formula that we can use for any derivative of x times e to the x. All right, so product rule, we have our first function as x, our second function e to the x. So our product rule says take the first function times the derivative of the second. What's the derivative of e to the x? That's a tough one. Yeah, it's just e to the x. There we go. So easy, it's hard. Plus the second function times the derivative of the first. And what's the derivative of x? 1. Now, if I just needed to find the first derivative, I would probably rewrite it. Actually, probably not. But because I want to find a general formula here in a minute, I'm going to factor out an e to the x. So now I'm going to find a couple more derivatives, see if I can come up with a general formula. So if I take the second derivative, I have the derivative of x times e to the x. But I already know the derivative of x times e to the x is right here. So if I didn't remember that, I could certainly go through the product rule again. But the derivative of x e to the x first times the derivative of the second plus the second times the derivative of the first. So that's the derivative of x e to the x. And then I have plus the derivative of e to the x. And the derivative of e to the x is e to the x. Right? If I factor out an e to the x, I would have x plus 1 plus 1. And way back in the dark ages when I did this, 1 plus 1 was 2. So I think I get that. Try a third derivative. Actually, before I do that, I'm going to do one more thing. Maybe. There we go. Just combining my like terms, and that way I can take the derivative of this. Just makes it a little bit easier. So again, I have that x e to the x. And its derivative gives me x e to the x plus e to the x. And then I have the 2 e to the x. And from Thursday, we had a rule about a constant times a function. We get that constant times the derivative of the function. And what is the derivative of e to the x? E to the x. That x e to the x plus 3. 3. That's a bad 3. Or if I factor out the e to the x, all right. Do you think you see a pattern? All right, so let's see if we have a pattern here. So if you ever see a function, oh man, a function with a superscript, an exponent in parentheses like this, that's going to indicate a derivative. So usually we quit with the slash marks after 3. So if we wanted the fourth derivative, you'd see f and then in parentheses 4 as an exponent x. For the nth derivative, what would we get? Yeah, so a couple ways you could write it. I like that way. That's awesome. You could also write it as x e to the x plus n e to the x. That's the same, just multiply the e to the x through. I just like it this way because it is, I don't know, to me it's easier to see. All right, so here we have a function defined as the square root of x times another function g of x. And we're told g of 4 is equal to 2, g prime of 4 is equal to 3. Find f prime of 4. So again, we have a product rule. We have our first function, square root x. Second function is just called g of x. We don't have an explicit form for that. So I'm going to take my first. And again, I would probably write the square root of x as x to the 1/2. times the derivative of the second. What is the derivative of g of x? Derivative of g of x is just g prime of x. Plus the second function times the derivative of the first, the derivative of x to the 1/2. Excellent. And now I want to evaluate that for x of 4. All right, 4 to the 1/2 power. 2.
Do you mean to put a plus sign in the middle of that?
You know what? I put an equal sign, didn't I? Yes, it should be a plus sign. Thank you. All right, g prime of 4. Plus 1/2 g of 4 is 2. 4 to the negative 1/2. That would be 1 over the square root of 4, which would be 1/2. And if I multiply and add that together, I get 6.5. Or 6.5, or 13 over 2, or whatever. That would be equivalent to that. So this is just a great way, well, I think it's a great way anyway, of kind of showing knowledge of the product rule without getting bogged down with a lot of functions. So you might see something like this on the AP exam on the multiple choice section, maybe on a test or a quiz in class, just because it really tests on the knowledge of what's going on with the product rule, or later we'll see it maybe with the quotient rule and other rules. So your assignment with the product rule on page 188, 189, 1, 3, 4, 9, 10, 15, 35, just part A, and 43. Problem 1, I believe, is going to give you a binomial times a binomial. And it's going to ask you to use the product rule and then and then multiply it out and take the derivative and show that you get the same answer either way. The rest of them are pretty straightforward. Product rule, and at the end we've got find the equation of a tangent line, your favorite type of problem. So quotient rule, hopefully we can guess that this is going to be division of functions. If you can't guess that, I guess I ruined it for you. So if we have some function capital F of x, and that's equal to the quotient, little f divided by little g, where little f and little g are both differentiable. And we should probably say that g of x is not 0, right? We can't have 0 in our denominator. Then we're going to derive how to get the derivative of the quotient. And we're going to do that by using what we know about the product rule. So the first thing I'm going to do is multiply both sides by g of x. And now I'm going to use the product rule on the left side to take the derivative, and I'm going to take the derivative on the right side. So the product rule, take the first times the derivative of the second plus the second times the derivative of the first and that's going to be equal to the derivative of little f. Now I'm going to use a little bit of algebra, because what I want to do is I want to get big F prime by itself. I want to find the derivative of that initial function, capital F. So I'm going to subtract capital F of x times g prime of x from both sides. That will leave me on the left-hand side with capital F prime. times g of x. And right away, I don't like this capital F over here. So I'm going to replace it. I'm going to get rid of it. And I'm going to replace it by what it's equal to. And it's equal to little f of x divided by g of x. All right. Everyone okay with that? We understand that, Mr. Gingrich? You just multiplied and rewrote it as a single fraction after the subtraction. It's exactly what I did. And because that fraction looks kind of lonely on the right-hand side, I'm going to use common denominators so I can write the entire right-hand side as a single fraction. So f prime of x, I'm going to multiply by g of x over g of x. And now to get f prime by itself, divide both sides by g of x or multiply by 1 over g of x. And we have our definition for the derivative of a quotient of two functions. Now, I'll be 100% honest. I never memorized g of x times f prime minus f of x times g prime all over g of x squared. Way back in the dark ages, when we're still using hammer and chisel to do our notes and things, I learned it this way. Right? I learned it as low d high minus high d low over low squared. About 15 years ago, I had some students say, "Oh, Mr. Gingrich, we got a better way. We got a better way. We got a better way." So what they did is very similar, but they just said low d high minus high d low, draw a line, and square below. So that's the way they remembered it. So if you can come up with just something to help yourself, a little mnemonic device or something, it can be useful. So find the derivative of y equals x minus 1 divided by 2x plus 3. Let's see, the derivative. Take the denominator. Times the derivative of the numerator. And what is the derivative of x minus 1? 1 minus the numerator. I want to be careful here because the numerator is in parentheses. Times the derivative of the denominator. What is the derivative of 2x plus 3? 2. All over the denominator squared. So because our function could possibly be reduced, I always simplify when I use the quotient rule. If I distribute the minus 2, and combine my like terms in the numerator. What do I get in the numerator? 5. You might say I got a high 5 there. I don't know. Maybe not. And then the denominator, I never multiply out the denominator, because if it can be reduced, it's going to be in that factored form. Okay? And then I also hopefully am not tempted to try to cross like reduce things that are being added, right? Because we can only reduce when they're being multiplied. So this is my derivative. So kind of like number one in your homework for the product rule showed just because it's a product, you don't have to use the product rule. You could multiply it out and take the derivative. Same with the quotient rule. And maybe more importantly with the quotient rule. By the way, you'll get a problem like that as well for your quotient rule practice. If I have a function that is 3x squared plus 2x to the 1/2 all divided by x, it's probably easier to reduce that fraction to get rid of the denominator and then use the power rule and the rule of sums. You know, so if I divide every term by x, I get that 3x plus 2x to the negative 1/2. And now that derivative is much easier than using the quotient rule, I think. You may disagree, and that's okay. Agree to disagree. Now this derivative just like so. Problem 31 asks you to find the tangent line and the normal line. Let's just do the tangent line on that one. Again, I don't believe normal lines are part of the AB curriculum, and I don't know how many times they ask it on the BC as well. So tangent line only is fine. Some good practice.